Ever wondered what happens to all the mechanical energy we waste every single day? The moving air from a fan, or the motion we never capture?
That invisible power gone forever. But what if we could reclaim it? What if even a humble ceiling fan could help us light our future?
That question became our mission, and that mission became Zynthera, a hybrid wind based electricity generation and storage system designed for everyday use.
Zynthera isn't a large wind turbine or a solar panel setup. It's a compact, efficient, and practical household contraption. It converts the rotation of a ceiling fan into electricity, clean, renewable, and stored for later use.
At its heart is a gear train that multiplies the fan's speed. This amplified motion drives a BLDC generator, which transforms mechanical rotation into electrical power.
The generated current flows through a diode, ensuring one way flow, no reverse losses. It then passes into a hi fi MPPT charge controller, which keeps the charging current optimized even when the fan speed varies.
From there, energy is stored in a 12-volt lithium ion battery, ready to power our 18-watt LED tube light, long after the fan stops spinning.
Let's trace the flow of energy step by step. The fan converts wind to rational rotational energy. The gear train optimizes torque and speed. The generator makes electricity. A diode prevents backflow. The charge controller protects and charges the battery. The regulator provides steady output. The switch controls power, and the tube light finally emits visible light.
Each stage plays a role. The fan provides motion, the gear amplifies it, the generator converts it, the charge controller stores it, the battery holds it, and finally, the tube light shines with the energy we once ignored.
But every machine has its limits. Energy isn't free, some is lost.
Let's talk numbers, clear and honest. Each stage has its own efficiency. Gear train 95%, generator 85%, controller 98%, battery 92%, and finally the wiring 98%. Multiply them together.
Well, let's multiply them. 0.95 multiplied by 0.85 multiplied by 0.98 multiplied by 0.92 multiplied by 0.98, which makes the total value of 0.7135, which in percentage is 71.35% overall efficiency. This means out of 100 units of motion, about 71 become useful electricity and only 29 are lost.
So, for a mechanical input of 50 watts, we get 50 into 0.7135 is equal to 35.67 watt hours of usable electricity. That's enough to run our LED tube light for about 2 hours or roughly 119 minutes.
Now, double the input to 100 watts. You get almost 4 hours of light. At 200 watts, almost 8 hours of illumination in a world that wastes electricity so easily. Even that recovery is powerful.
We didn't stop there. To make Zynthera more efficient, we designed upgrades. First, a larger battery for extended use. Second, an improved blade system with aerodynamic design for better wind capture. And finally, third, a ducted housing that channels airflow directly onto the fan blades.
We added a digital voltmeter and ammeter to monitor generation and battery storage in real time, so users can actually see energy being produced and stored. And with a high efficiency charge controller, a system stays stable even at variable speeds.
Every improvement made the machine feel more alive, more responsive, and more human.
Imagine this, instead of a single setup powering one tube light, Zynthera connects to a common home battery system, even small powered generator in the house that feeds energy into one stored battery.
The result? A self recharging home microgrid. Lights, fans, and devices all sharing one intelligent storage. No wasted energy, no sudden blackouts, just continuous, smooth, and sustainable flow.
And with better management, the system efficiency rises to 74.2%, proving that collaboration isn't just human, it's electrical too.
Of course, no system is perfect. Losses occur due to friction in gears, heat in the generation coils, and resistance in wires. Even our battery loses a few percent as it charges and discharges.
But each loss taught us something about engineering, patience, and persistence. Because perfection is not absence of loss, it's the courage to minimize it.
1 hour of Zynthera saves nearly 0.0357 kWh of grid electricity. Multiply that across homes, schools, and institutions. The savings grow exponentially. It's small energy from small motion, but multiplied by millions of households. The result is transformation.
Imagine a day when every ceiling fan in India silently helps light its own room, turning air movement into hope and innovation into action.
Zynthera isn't just a project, it's a promise that even in ordinary motion, there lies extraordinary potential.
It proves that saving energy isn't about massive turbines or vast solar farms. It's about thinking differently, about using what we already have.
Every spin of the fan, every rotation of a blade is a heartbeat of possibility, and together they whisper the same truth.
From concept to calculation, from design to demonstration, we built a system that reminds us power can be found in the simplest motions.
We are Nidhish and Aradhya, and this is Zynthera, our step towards a cleaner, brighter, and more self reliant future. Thank you and have a great day ahead.